Hello, welcome everyone, welcome back to my channel. Today we are doing linear inequalities and this is especially for KS3 actually. But those who haven't done it in their case 3 as well as they are not able to remember all the stuff and you are right now in GCSEs, definitely it's gonna help you. And for all those, like if you are studying any curriculum, that is a second Indian curriculum or CBSE, ICSE, IGCSE, it's definitely gonna help you. But before that, like I say in my every video, I am running the revision classes and especially the doubt classes for GCSE and for A levels. So like if you have doubt in a particular topic or in a particular concept, then definitely you can book your class. And also I am running classes from year 1 to year 13 for all subjects. I have tutors, they are highly experienced. So all you need to do is just drop us an email at exactacademy@gmail.com and you just need to post your queries there and then we'll coordinate accordingly. So let me start with linear inequality. See, a linear inequality or a linear expression is something whose the variable like x has power 1. That's called a linear expression. Like if I say y plus x equals 1, it's a linear equation. Y plus x is a linear expression because both the variable has 1 power over it. X plus 3 is a linear expression. But when I introduce equals to sign, this becomes an equation. But if I introduce an inequality sign, then this becomes inequality. Now let me explain you what exactly inequality means. Inequality means that your left hand side and right hand side are not equal at all. If I'm writing x plus 1 equals x plus 3 equals 1, it means there should be some value of x. When I put it here, it will become equals to 1. So basically left hand side and right hand side both are equal and that's why there is an equals to sign in between it to represent that they both are equal. It's just like a weight balance, a manual one. So what you will do, you have two pans to separate, and if you are placing the same weight on both of them, it will be balanced, right? That's the equality. But if something is lighter, something is heavier, then there will be an inequality because now one is greater than another. And same thing we have to represent. If I say x plus 3 1, this is called greater than 1 because beak this point represents the smaller one, the number, the variable to which this apex is pointing, that is your smaller one, whereas that open ended is the greater one. So we always write the greater values here and smaller values here. So what I can write it here. So here I have written some definitions. That is what are linear expressions. The expressions which have linear terms in it, that means the highest variable of x is 1. Whereas equations is if you have introduced an equals to sign. Here is an example that 2x plus 1 is greater than is equals to y. 4x minus 3 is equals to x plus 2. So when there is an equals to sign, this is linear equation. Inequalities represents when one value is greater or lesser than the another value. Here this is the symbol that is used to represent the linear inequalities. Now see this one, the inequality is like this. This beak, this apex, the meeting peak thing points towards the smaller value always, whereas that open-ended always points towards the greater value. That means here I have written an example that 3 is smaller than 4. We know that 3 is smaller than 4. So how we can represent it? By showing it that peak is pointing towards 3. This side is pointing towards 3. It represents that 3 is a smaller value out of these two. Because we are comparing two values. Out of them, definitely 3, the peak is pointing towards it. It means that 3 is the smaller one. Whereas the open-ended is pointing towards 4th. It represents the 4 is a greater one. Now, let me see inequalities are like the different ways to show an inequality. The first one means x is greater than 3. So I can write x is definitely because the open end is pointing towards x. So I can say x is greater than 3. For next one, x is greater than 3, but this sign is called equals to sign. It's actually greater than and equals to, but when you just combine it together to show that it's greater than equals to, we can write it like this. It means that x is including 3 as well. So when I represent it on a number line, you will get a better idea what does this mean. But as of now, try to know what it is. It is x is greater than and equals to, because it is including 3 as well. For the next one, definitely the peak point or the apex is pointing towards x. That means x is smaller than 3. So I can say x is smaller than 3. Even you can write that 3 is greater than x, but a better way is x is smaller than 3. And here x is smaller than and equals to 3. Now representing this inequality on a number line, this will give a better idea how what's the meaning of inequality, what is the meaning of greater than equals to, smaller than, greater than, smaller than equals to. So the four things that we have written here, I am representing now each of them on the number line. So starting with x is greater than 3. X is greater than 3, that means x takes all the values that are greater than 3 but not 3. That's the meaning of this one. You are not supposed to include 3. And that's why when you're going to represent it, it will be like a circle and then a straight line. A circle and a straight line, that means the values, all the values, it's going till infinite. That means we don't know where the numbers will continue, all the values, and it should be greater than 3 and infinitely. So I'm just representing it with the arrow. That's the meaning. And this open, like I haven't filled this circle, it's unfilled circle. It's unfilled circle represents that I am not including x at 3 at all. So here I have written the representation of it. That means x greater than 3 represents that x can take. That's the meaning of inequality. When we solve any equation, we will get one value. When we solve a linear equation, we get a one value of x that will satisfy the given equation, that will solve the given equation. But inequality is something which will give you the range. Because if something is greater than smaller, so obviously it can take an array number of values that can make it greater than. And that's why when you solve an inequality, you will get a range of values, and here x greater than 3 represents all the values of x that are greater than 3, and they are infinite values. But this represents that it's not including x, and that even on number line we represent it with the unfilled circle. The unfilled circle means we are not including x at all. Let me see the representation of another inequality, which is x greater than 3 equals 3. So here there is an equals to signs. The only difference here is x is still greater than 3, but here we are including 3, and to represent it in a number line we have to use filled circle. So here it means that x is greater than equals to 3, and we are using the same. We'll draw a circle here and then a straight line pointing towards right because it's greater than, so like continuously going. Only difference here is I'm just gonna fill this circle now. So it represents x is greater than 3 equals to 3, and here we have written the description of it. The next one is x is less than 3. Here we have to include all the values of x that are lesser than 3. To represent lesser than 3, we have to move towards left side, because we are looking for the values that are smaller than 3, 2, 1, -1, and so on. So what I'll just draw a circle over 3, and then instead of moving towards right, because right will take me to the greater values, but I am looking for the smaller values, so it will go towards this. It represents that all the values that are smaller than 3. There is no equals to sign here, and that's why I'm not using a filled circle. It will be represented by unfilled circle. And last one is x is smaller than equals to 3. Here we have to do the same thing. That means we need to represent it with the number line, and we have to represent that it is including all the values that are lesser than 3. That means more towards left. Only difference is we are going to fill the circle here. That's it. A filled circle will represent that it is including 3. So just like I have written the description of everyone, I'm just writing description right below it as well. So this was about the basics. What is the meaning of inequality? Now let me see how we can solve it. If you know the linear equations, then linear inequalities are very simple to solve. If you know the basics of linear equations, it's completely fine. If you don't know, you can go back and see my videos I have uploaded on linear equations. It will definitely going to help you, and then you can come back here for the linear inequalities. So now let me see how we can solve linear inequalities with the first question. See, first one is finding linear inequalities when variables are on one side. That means our first equation is x plus 1 greater than 3. Simple. Variable is on one side, on either side you can see the constants here. This is just like an equation. What we do to find an equation, we isolate x. That's the the base. Whenever you are finding the answer for x, roots of x, zeros for x, what you are doing, you are just finding, you're just isolating x. You're just making x alone on one side, and same we have to do it here. If I'm doing it here, I'll transpose 1 to the right hand side, and on doing, I'll get x is greater than 3 minus 1. Whenever you transpose, the sign gets changed. So 1 was positive on left hand side, it will become right on negative, like on right hand side. So it will be x is greater than 2. That's the solution of your inequality. So here you just need to transpose it, solve it just like how you solve any linear equation. Take the example of the next one, which is suppose 2x minus 3 less than 4. So you will do the same thing, transposing. So I'll transpose 3 onto the right hand side. It will become 2x less than 4 plus 3. That is 2x less than 7. Still x is not isolated here. What I'm doing, isolating x. Still you haven't done it, so you need to divide it by 2, because 2 is still in multiplication with x. So dividing both the sides by 2, you'll get x is less than 7 over 2. So this is our linear inequality. This is how you can solve it. Let me take one more example. This is x over 2 less than 3. So I cross multiply here, or I can say multiply both the sides by 2. You will get x is less than 6. So this is how you can solve. So what I did, I just cross multiplied, or it means the same what you are doing, multiply both sides by 3. Now let me see the next question, in which we have to solve the inequality as well as we have to represent it on a number line. So let me see how we can solve it and how we can represent it in a number line. Though I have explained you both, now it's just a combination of both of them. Simply we need to explain it first, solve it first. So 2x plus 3 less than equals to 2. So need to transpose. Very first thing is, so 2x less than equals to minus 3. It will give you 2x less than equals negative 1. Whenever we transpose, change the sign. Now still x is not alone. We need to divide both the sides by 2. It will give you x is less than equals negative half. So we know that x can take all the values that are lesser than or equals to negative half. So I'll draw a circle over negative half, which is negative 0.5. It is here. And then because it's talking about all the lesser values, so it will go towards left. This is how we can represent. But one more thing, because it is including x as well. So negative half as well. So just you need to fill it up and you will get the answer. This is required inequality. it's representing negative half here. Let me solve the next one. 4x minus 7 less than negative 2. So transpose it here onto the right hand side. 4x less than equals negative 7, sorry, less than, just less than, no equals to, negative 2 plus 7. I'm just changing sign when I'm transposing it. So 4x less than 5. And now divide both the sides by 4. So x is less than 5 over 4. It represents 1.25. We know that 1.5 will lie between 1 and 2. And between 1 and 1.5 we'll get 1.25. That means this is 1.25. I'm just approximating and you'll get a circle here. X takes all the values that are lesser than 5 over 4. So it will go towards left simply. And this represents the inequality on a number line. And it's going to be unfilled circle because it's not including 5 over 4. Now let me try to solve more questions. So here solving inequalities when variables are on both the sides. It's simple, you just need to separate it out, the variables on one side and numbers on another side. So I'm just transposing it here. When x will be transposed onto the left hand side, same thing will happen with the x what happens with the numbers. That means it will change its sign. So it will become 4x minus x, and plus is already here, plus 3 less than equals negative 4. 4x minus x is 3x. If you subtract 1x from 4x's, definitely 3x will be remaining. 3x plus 3 less than equals negative 4. Now we need to bring 3 onto the right hand side like this. 3x is less than equals negative 4, negative 3. So it's negative 7. 3x is less than equals negative 7. Now finally to isolate x, you just need to divide both the sides by 3. So x is less than equals negative 7 over 3. The question is all about just solving inequalities. We need not to represent it on a number line. Moving on to the next one. It says 7x plus 3 greater than 8x minus 4. So doing the same thing, first I need to transpose 3 on to here. Either like it's totally on you. You can transpose number first, variable second, or the vice versa. So I'm just transposing it here. This will be 7x greater than 8x minus 4, and 3 will become negative, which is negative 3. So 7x greater than 8x minus negative 7. Minus 7. Now bring it to left hand side. So 7x minus 8x greater than negative 7. This is minus x greater than negative 7. Now I need to multiply both the sides by negative 1, and whenever we do it, the inequality sign will change. Now why it changes? It's a simple thing. 3 is greater than 2. Obviously 3 is greater than 2. But if you divide both the sides by negative number, now it's negative 3 and negative 2. Which one is greater? Obviously negative 2 is greater. On number line we know this is 0, 1, 2, 3, negative 1, negative 2, negative 3. On positive side, 3 is definitely greater than 2 because 3 comes after 2. But when you multiply both the sides by negative sign, it will become negative 3 and negative 2. And on number line, we know that negative 2 is greater than negative 3 because as you keep on moving towards left side, you are getting more smaller and smaller number. That means 3 is smaller than negative 2. So it should be like this, and clearly the inequality has changed. It was previously towards right, the apex, now apex is on left hand side. This is the reason whenever we multiply both the sides by negative number, the inequality sign changes. So finally on multiplying both the sides by negative 1, it will be x is lesser than 7. That means x can take all the values that are lesser than 7 except for 7. Now the next is linear inequalities including brackets. So it's simple, you just need to expand the bracket first and then solve it. So when I expand the bracket, I need to multiply the number outside the bracket with every term inside the bracket. So 2 times x will give you 2x, and 2 times negative 3 will give you negative 6 less than equals 4. Now bring 6 to the right hand side. You will get 2x less than equals 4 plus 6. 2x less than equals 10, obviously 6 plus 4 is 10. And finally, to isolate x, we need to divide both the sides by 2. So x is less than equals 10 over 2, which is 5. This is final inequality. Here, the next one, we need to do the same thing. That means multiplying. We need to just expand the brackets. So 4 times x is 4x. 4 times 1 is plus 4. Greater than 2 times x is 2x. And 2 times negative 3 is negative 6. Now just start your isolating process, transposing. So I'll bring it here. So 4x minus 2x plus 4 greater than negative 6. 2x plus 4 greater than negative 6. Bring 4 onto right hand side. This will give you 2x greater than negative 6, negative 4. Obviously sign will change. 2x greater than negative 10. Divide both the sides by 2. You will get x is greater than negative 5. So x can take all the values that are greater than negative 5 but not negative 5. Next is linear inequalities including fractions. So when we include fractions, it's just like you have, if you have definitely studied the linear equation, so it would be very simple for you to understand this part. That means first we need to remove this denominator, and for that I'm just multiplying both the sides by 2. So what I'm doing, multiplying both sides by 2. So this will be 2x plus 1 greater than 6, because I have multiplied both the sides by 2. So 3 multiplied by 2 will give me 6. Now transposing 1 to right hand side, 2x is greater than 6 minus 1. 2x is greater than 5. And finally, to isolate x, divide both the sides by 2. You will get x is greater than 5 over 2. That's the final answer. The next one, we have to do the same thing because 3 is in denominator. We need to multiply both the sides by 3. So 3x minus 1 less than 2 into 3, which is 6. Transposing it here, you will get 3x less than 6 plus 1. 3x less than 7. And divide both the sides by 3. Finally, you will get x is less than 7 over 3. This is final inequality. That means all the values of x that are less than 7 over 3. Now moving on to this one. It says dealing with two linear inequalities. Two equalities are there in the one frame. Here that x plus 1 is greater than equals 3. It is greater than equals 3 but less than 4. That means this expression x plus 1 4 is lying between 3 and 4. It's not necessary that always x would be like this, completely greater than some number, completely lesser than some number. So there can be a range as well. So whatever, here also your main aim is to isolate x. If you're isolating x, whatever you're doing with x, like with the middle part, the same you have to do on left hand side and same you have to do on right hand side. That means if x plus 1 is here, we need to remove 1 from it. In order to isolate x, we need to subtract 1 from all the sides. So I can say subtracting x from all sides. Whatever you're doing with one side, you're supposed to do with all the sides. So it will be 3 minus 1 less than x plus 1 minus 1, 4 minus 1. So this is 2, x and 3. That means the value of x, the range of x is lying between 2 and 3, whereas you are including 2 but not including 3. So it can be represented like this, that 2 here, x is lying between 2 and 3. This is final our inequality. Only difference is we are including 2. So this represents that x is greater than equals 2 but lesser than equals 3. Let me do one more question, or like one more. Say this one. It says 4x plus 1 2 plus 2 over 2 is greater than 4 but less than equals 13. So this value, only this value is lying between 5 and 13. We have to find the range for x, that x is like lying between which two values. And as I told you, your main aim is to isolate x. And how will you isolate x? Whatever you're doing with the middle part, you're supposed to do on left and right both. In order to isolate it, my first step is multiplying all sides by 2. So multiplying all sides by 2, we will get 5 into 2 as 10. 4x plus 2, because divided by 2 into 2 will cancel out each other, and this will be 26. Next step is subtracting, because here the 2 is extra 1, so obviously I'll subtract 2 to every side. So subtracting 2 from all sides, this will be 8 less than 4x, because you have subtracted 2, 24. Now finally divide all sides by 4. So 8 by 4 is 2, 4x by 4 is x, and 24 by 4 is 6. So this is our final inequality. Ultimately, we want our x to be alone at the end, and in order to do so, whatever I'm doing with the middle part, I'm supposed to do on either side of it. So finally, I'll get inequality that lies between 2 and 6. Let me represent it on a number line. So here it says at 2. So let me make a circle over 2 and over 6. So it represents that x is lying in between 2 and 6. But there's a difference that here we are including 6. So just fill it up. So it represents that x is greater than 2 but lesser than equal 6. So that's it all for today, the inequalities. As I told you, it will be helpful for KS3, GCSE, ICSE, CBSE, IGCSE and so many curriculum. You can get the help from this one. And in the next class, we'll be doing the worksheets. So that's it for today. Thank you everyone. Have a great day.